Hello, everyone. Welcome and thank you for joining us for Teledyne ISCO's Pumps September webinar. Today's webinar is focused on maintenance considerations for syringe pumps. This webinar is being led by Kevin Lehl, one of Teledyne ISCO's service engineers. If you have any questions or comments during the webinar, please utilize the chat function within Zoom, and all questions will be answered at the end. And at this time, I will turn it over to Kevin.
Hello, everybody. Today we're going to talk about pump maintenance, and we're going to cover four of the main things on the pumps, which would be changing your pump seals, lubricating the pump, pressure transducer calibration, and then any type of field verification procedures. When it comes to changing the seals on the pumps, we're going to talk about changing seals, and on our syringe pumps we have several different types of seals. The standard seal that ships out with every pump that goes out the door is a graphite Teflon seal, and that seal has a Hastelloy spring. The other options we have, depending on if you have high temperature needs, we have a high temperature seal. We also have a low pressure seal, which is good for customers that are operating maybe at like atmospheric pressures or very low pressures. We have a ultra high molecular weight polyethylene seal, which is good for aqueous applications. And then we have a virgin or pure Teflon seal, which is the recommended seal for any customers that are pumping ammonia. So those are the seal options that we have, but the standard seal would be the graphite Teflon seal, and that's going to be good for most applications. Unless you're doing high temperature, most applications can be covered with the standard seal. When you replace a seal, some of the tools that you're going to need, you'll need a 1/8 inch Allen wrench, and that's to loosen the cylinder locking screw that locks the cylinder into place in the mounting block. You'll also need a 1/4 inch Allen wrench to remove the piston retainer, and that piston retainer is what threads into the piston base and secures the piston. As far as lubrication, we'll get to that later, but you do have a lubrication accessory package that has lubricants to lubricate the ball screw, and also the worm gear in the bottom of the pump. We have a lubrication or soak pad that you lubricate that pad with, that then is in constant contact with the worm gear. Also, as an optional accessory, we have wrench kits for the pumps. And the wrench kits aren't absolutely necessary, but they do help when you are changing seals. They do make it a little bit easier. And in the photo, included in the wrench kit is a clamp that clamps around the cylinder. And then with that clamp on the cylinder, you take the mating wrench, and that allows you to easily remove the cylinder from the mounting block. And as indicated, it's not necessary, but it does make it a little easier when you are changing seals. So the first thing you're going to want to do when you're changing seals is you're going to want to put the pump in a constant flow mode, enter a flow rate, and run the pump empty all the way up to the top. And when it interrupts your upper limit sensor, the pump will automatically stop on its own, and you'll get a reading on the display of the controller that will tell you the cylinder's empty. At that point, you'll be ready to go on to the next step, which is removing the cylinder. So what we want to do is you'll want to disconnect your AC power cord from the back, and then you'll also want to unplug your pressure transducer cable from the back and just wrap it around the top of the pressure transducer cap at the top of the cylinder, just to kind of keep it out of the way. So we unplug your power cord, disconnect your pressure transducer cable from the rear, and then just wrap your cable around the transducer, and at that point you'll be ready to remove the cylinder. So your cylinder locking screw is at the front of the pump. There's a recessed opening there, and as indicated, it takes a 1/8 inch Allen wrench, and just loosen that maybe 2 or 3 turns with your Allen wrench, and then that will basically remove that locking screw from the cylinder, and that's going to then allow you to unscrew the cylinder from the cylinder mount. Now here's where, if you do have the wrench package, you can attach your clamp to the cylinder. And basically the clamp is 2 halves. You clamp each half around the cylinder, and then there's 2 Allen bolts in the clamp, and you use your 1/4 inch Allen wrench to tighten the clamp to the cylinder. And you want to get it on there fairly tight so that it doesn't slip on you when you're trying to remove the cylinder. And here's a photo of the cylinder clamp on the cylinder, and then in the wrench package we have the mating wrench that fits onto the clamp, and then with that wrench and clamp you can unscrew the cylinder. Now most times if you don't have that, you can unscrew it by hand, but there are occasions where over time that cylinder can get kind of tight in that mounting block, and sometimes you have to have the wrench package, or some customers have used a strap wrench, and we have had pretty good luck with customers that have used a strap wrench to remove the cylinder. So then basically with the wrench, you just unscrew the cylinder. It takes quite a few turns. It's a pretty fine thread on the cylinder. So once you've got the cylinder totally unscrewed from the mount, then basically you just lift straight up on the pressure on the cylinder to remove it from the push tube. And once you have it removed from the push tube completely, you will then have access to the piston. And so you just lift straight up. And you can see as you're lifting, you'll start to expose the push tube. And then once you've cleared the push tube by removing the cylinder, you will then have access to the piston assembly. With the cylinder removed and access to the piston, on top of the piston retainer, that's where you'll insert your 1/4 inch Allen wrench. And with the 1/4 inch Allen wrench, you'll unscrew the piston retainer from the piston base. Once again, that's counterclockwise. And then once you've unscrewed that, you can remove it from the piston base. Now in the photo, once you'll see there you have the piston retainer with the piston seal on there. What's below there, that middle piece, is the wear ring, and that's it's made of bearing grade PEEK, and what that does is that keeps the piston centered when it's inside the cylinder and the piston is moving up and down. That wear ring keeps the piston centered. And then the item below there is the wiper seal. And the wiper seal kind of just, as the name indicates, it kind of wipes the cylinder as the piston is moving up and down when you're running the pump. When you replace the piston seal, after you've removed the old one from the piston retainer, when you put the new one on, you always want to make sure that the spring side of the seal is always facing upwards. We have had occasions where the seal gets put on upside down and it leaks when the when they try to run it. So always make sure that when you replace the seal, that spring side is facing upwards. You don't want to have the spring side facing down, and you try to not handle the seal a whole lot. Be careful when you're replacing it, because it is easy to nick the seal if you're not careful. And then basically you reattach or you reinstall the new seal onto the piston retainer. And then fully seat it on the retainer, and then you can reinstall it on the piston base. Now, before you install it on the piston base, we recommend taking a little bit of the black ball screw lubricant that's called Never Sees, and just put a really fine coating of that on the threads of the piston. The reason for that is once you do that, that will make it easier in the future when you go to have to change a seal again for preventative maintenance, or if you have a leaking seal. It just makes it a lot easier, because if you don't have that lubrication on the threads and you tighten the piston retainer back onto the base, if it gets over-tightened, you do run the risk of potentially galling the threads, so that when you try to take it off the push tube the next time, you may not get it off. So it's a good idea to always put a really thin coat of lubricant on those threads. Doesn't have to be a lot, just a thin film wiped around the threads of the retainer. Then go ahead and, with your seal back on the retainer, you'll thread that back on to the piston base. Most customers, a majority, are not going to have a torque wrench. If you do, we torque it to 20 foot-pounds. Basically, once you get it tightened onto the retainer tightened onto the piston, I would suggest just pretty much as tight as you can get it with the Allen wrench. It doesn't have to be horribly tight, but you want it tight enough so that as the piston is running up and down, it can't become unscrewed from the piston base. I have seen that in the past, where if it wasn't tightened securely, over time it came loose and separated from the piston base, and then the piston retainer with the seal gets stuck inside the cylinder. So you just want to make sure that you get it on fairly tight, because you don't want it to come loose. Once again, when you tighten it, it's just a clockwise direction for tightening. And then with your Allen wrench, go ahead and tighten it. Now, the wear ring typically does not have to be replaced. My recommendation would be that if you have the cylinder off and you're replacing the piston seal, it's probably a good idea to just go ahead and replace the wiper seal while you're at it. It's not necessary, because the wiper seal isn't doing any sealing, so if you only have the one seal, that's fine. But I generally, when we have them here in-house for repair, we'll typically replace both seals. So when you order the seal, they don't come as a kit. You have to order the quantity that you want. So if you're going to replace both the piston and the wiper seal on the pump, you would need to order a quantity of 2. And the one thing that you'll notice that's different about the wiper seal, the spring side faces downwards. So when you're looking at your piston assembly, the piston seal on top, spring side is facing up, and on your wiper seal, the spring side faces down. The only time where that will be different is on our 1000D pump. That pump comes standard with a set of wash glands, and what those wash glands allow the customer to do is to have a continuous piston wash across the piston seal. So in that case, because we have that ability to have a piston wash, on the 1000D, both of your seals, the spring side will be facing up. But that's the only pump you'll see that on. On all of our other pumps, like the 260D, the 500D, the 100D series, 65Ds, it's going to be a situation where your piston seal, spring side will be facing up, wiper seal, the spring side will be facing down. And once you've got your piston seal replaced and the retainer back on and tightened, you'll want to slide your cylinder back down over the piston. And it's just basically you guide it onto the piston, make sure that you're fairly well centered when you put it over the seal, and then basically just start pushing the cylinder down until you've got it all the way down into the mount, and you start tightening it into the cylinder mounting block. One thing I would recommend, though, before you put the cylinder on, is to inspect the inside surface of the cylinder. You can take a flashlight or a cell phone light and go ahead and shine that down on the inside surface of the cylinder. What you're looking for is to make sure that you don't have any scratches or score marks on the inside surface of the cylinder. Basically, when you look inside the cylinder, it should be a mirror finish with no deep scratches or score marks, anything like that. Because if the cylinder is scratched or has a score mark that's deep enough, if you put the cylinder back on and pressurize the pump, it's going to leak. Because those scratches are going to prevent the piston seal from sealing against the cylinder wall, and the material or liquid that you're pumping is going to get past the seal, and you'll still have leakage. So you want to make sure that your cylinder is in good condition, and as I indicated, it should be a mirror finish. If there's like residue on the cylinder, then I would go ahead and before you put the cylinder on, I would rinse it out with something like water, or you can use like isopropyl alcohol, methanol, something to rinse the cylinder out if there's any like residue that's left behind on the cylinder from whatever you're pumping. But make sure that before you put the cylinder on, it is in good condition and you don't have any scratching or score marks on the cylinder. If everything looks okay, then you can go ahead and put the cylinder back on and get it tightened down into the cylinder mounting block. Once you've got it tightened down into the cylinder mounting block, go ahead and tighten it down all the way that it will go. And then what you want to do is you want to back it off in your counterclockwise direction just enough so that your pressure transducer at the top is positioned so that your cable on the transducer is coming straight out the back and your ports are lined up on your left and right side. So you'll tighten it down all the way until it bottoms out, and then you want to make sure you back it off probably at least a half a turn or more until your pressure transducer cable is coming straight out the back and your ports are lined up perpendicular. Then with the cylinder threaded back down into the mounting block, you'll take your 1/8 inch Allen wrench and you'll go ahead and you'll retighten your cylinder locking screw to lock the cylinder in place. Reconnect your power cord and your pressure transducer, and then you can go ahead and reconnect your tubing lines to the pump. And then the next thing you probably want to do is later on or at some point perform a leak test on the pump to make sure that the new seal has taken care of any leaking issues you have or that you don't have any leaks. Once you have the cylinder back on, since you have the pump in the empty position, you'll want to go ahead and lubricate the pump. We recommend, as far as the lubrication, there's two places, the ball screw and then the worm gear. We recommend lubricating the ball screw every 2 years or every 6,000 pump strokes as far as lubrication. Lubrication kit has two lubricants. We have an Aerosol lubricant. It's kind of a red colored lubricant. It almost has the consistency of like syrup. That's the lubricant that you'll use on the soak pad in the bottom of the pump. The black lubricant, the Never Sees, is what you'll use on the ball screw. Once again, since you're changing the seal, you already have the pump empty, so that'll be taken care of. There's two tower covers on the pump, and they're secured with 2 screws on each side. You just loosen those 2 screws on each side, and then that will allow you to remove the 2 tower covers. And then the 2 tower covers come apart, and that will allow you to have access to the ball screw, which will, at this time, with the pump in the empty position, will be fully extended. The next step would be to go ahead and remove the case bottom cover of the pump. The older pumps have 4 screws. Our newer pumps, we have 6. So depending on the age of your pump, you'll either be removing 4 or 6 case bottom screws to access the inside of the unit where the lubrication wheel is at. And then go ahead and, with everything removed as far as your screws, you can go ahead and remove the case bottom cover. And there's the, it's kind of a felt pad, and that's the lubrication wheel. And that lubrication wheel is what you'll use the red Aerosol lubricant on. And you just want to put a fairly good amount on that soak pad, because that soak pad is always in contact with the brass worm gear when the pump is running. And so just soak it pretty good, and that's really all you have to do. And then that soak pad then will constantly keep your worm gear and also the horizontal worm, which you can't see in this photo, but it will keep those 2 items constantly lubricated. And you don't want to over lubricate it, because that can kind of get a lot of that oil kind of slung around on the inside of the pump. So just soak it, but you don't have to go overboard. Just as long as the pad is soaked through. The ball screw, you'll take your black Never Sees lubricant and like a wooden tongue depressor. And what you'll want to do is take a small amount of that and run that along each side of the lead screw. Run it from top to bottom on each side, and just run it down to lubricate each side of the ball screw. And you'll see there where you're just running it alongside the length of the screw. Because then when you refill the pump, as the pump is refilling, that lubricant that you've placed on the ball screw will get worked into the ball nut as the pump is refilling. And so basically, with that lubrication on the screw, you're lubricating the screw and also the ball nut, which inside that ball nut are ball bearings, which travel along the lead screw or the ball screw as it's either running up or down. And just run a bead on each side of the lead screw. Then go ahead and put your tower covers back on. You'll just make sure that when your tower covers are on, the rear tower cover has a slot in it for the drain tube to move up and down. And then your front tower cover has your access hole for the cylinder locking screw. And then also go ahead and put your case bottom cover on. Be careful not to pinch any wires when you're putting the case bottom cover on. Just make sure that all your wires are tucked inside the pump and that when you put the cover on, nothing is getting pinched, no wires in between the case bottom and the case top cover. We do have a technical bulletin that does have information on the lubrication and the maintenance section of the pump, and that's Technical Bulletin 22, which is those technical bulletins are all on our website. Okay, the next step as far as preventative maintenance is concerned would be a pressure transducer calibration. Now, to do a pressure transducer calibration, you would have to have an external pressure gauge so that you can compare the pressure that the pump is at versus what the pressure on the controller is telling you. So you'll need a manual valve, a voltmeter, and an external pressure gauge. And there's just kind of a diagram there that shows kind of a setup of a pump with an external pressure gauge connected to it, an on-off valve, and then a reservoir to fill the pump with water. You'll need to remove the top cover on your pressure transducer. There's 3 screws that remove that top round cover, and that will then give you access to the pressure transducer circuit board that's located on top of the pressure transducer. And on the inside of the pressure transducer, once you have your cap removed, that will give you access to the circuit board. Now, on the pressure transducer circuit board, the board itself is covered with a clear potting compound, and that's to prevent any condensation or temperature changes that the pressure transducer might be seeing. It kind of insulates that from those. But you will have access to the 2 potentiometers that are used to calibrate the transducer. The one potentiometer is your span adjustment. The other one is your zero adjustment. On the circuit board, the span adjustment will be numbered on the board as number R53. The zero adjustment will be numbered on the board R61. Some of the later pumps or the newer pumps, it will actually say gain and zero on the circuit board. And this is just kind of a setup that we would maybe use back in our service area. We have our external gauge. We have our source, and you want to test it with water. So we have our external pressure gauge connected to the pump, and then the other side of the other port of the pump would be plugged off, because basically you're going to be running the pump in a constant pressure mode with the pump basically dead-ended. It's not going to be pumping anywhere downstream. You're just going to be building pressure inside of the pump with the external pressure gauge connected to one side of the pump. back here. We have the pressure check, the leak check, as far as field verification procedures, and that's in Technical Bulletin TV 05. So on your pressure check, what you're going to want to do, I'm going to go to the next page here. You'll put the pump in the constant pressure mode, and the pressure that you'll enter first is 1,000 psi. You'll then go ahead and with the pressure gauge connected and set to 1,000 psi, your inlet valve will be open, and any air that you have in the system after you fill the pump, you'll purge any air out of the pump. You'll still leave your inlet valve open, and you'll go ahead and press the zero pressure key on the controller. Let me go back. I'm sorry. Before you do that, you'll want to adjust the potentiometer R61, your zero potentiometer on the pressure transducer board. You'll want to adjust that until you have a zero reading on the controller. So you'll adjust that potentiometer for a zero reading on the controller, then go ahead and press the zero pressure key on the front panel of the controller. You'll set your pressure to 1,000 psi in the constant pressure mode, press the run key, and the pump will run up to 1,000 psi on the controller. Then what you'll do is you'll go ahead and you'll compare that reading on the controller to what your gauge is reading. So what you want to do then is you'll want to adjust R53 so that your external pressure gauge matches the pressure reading on the controller. So R53 sets your span. So once you've got it under pressure and it's stabilized, then you'll adjust R53 so that your pressure gauge matches the reading on the controller. So in this case, you would adjust R53 so that your pressure gauge reads 1,000 psi, which will match the pressure reading on the controller. Then the next thing you'll want to do is, I'm going to go back, this step isn't in here, but you'll want to go ahead and after you've adjusted for 1,000 psi, then you'll go ahead and enter the maximum pressure of your pump, whatever that is for the pump you're working on. If it's a 500D, you would enter in the maximum pressure, which is 3,750 psi. And once again, you'll let the pump come up to that pressure, let it stabilize, and then if you need to readjust R53 slightly to match the external pressure gauge reading to the pump, you can go ahead and do that. So basically it's a two-point calibration. We're adjusting at 1,000 psi, and then we're also adjusting at the maximum pressure of the pump. Okay. The next thing you'll want to do then is a leak check of the pump. And we always do our leak tests at the maximum operating pressure of the pump. When you run a leak check, you're going to have the pump dead-ended. You'll have both your inlet and outlet sides of the pump closed off. And we always do our leak tests with water. So with your pump, both sides of the pump closed off, you'll have it in the constant pressure mode. You'll enter in the maximum pressure for your pump, whatever pump you're running, and then you'll press the run key. You'll let the pump run up to pressure, and then once it reaches pressure, don't press the stop key. Just leave it running in the constant pressure mode, and let it stabilize for 15 to 30 minutes. Let the pump stabilize out. And then after it's stabilized, after that 15 to 30 minutes, you're going to go ahead and you're going to record a volume reading on the display of the controller. You'll record that volume reading, and then you'll continue to let the pump run for at least 30 minutes. I would recommend maybe an hour, maybe even 2 hours. Just let the pump run under that constant pressure condition as far as the leak check is concerned. Then after that time frame, whether it be an hour or 2 hours, you'll go ahead and you record an ending volume. Then with your starting and ending volume, you'll subtract your ending volume from your starting volume, and that sum divided by the number of minutes that you've been running the leak check will give you your leak rate of the pump. We do have a seal bypass leakage specification on all of our pumps. So for like the 260D, 500D, 100D, that leakage spec is less than 1 microliter per minute. Anything over that, we consider the pump not passing the leak specification. On the 1000D, we allow 1.5 microliter per minute bypass leakage specification. Anything above that, in our eyes, the pump would not pass the leak spec when you're running that leak test. On a flow rate check, the D-series pumps we do not have a flow rate adjustment. The system uses a phase lock loop system. There is a tachometer or an encoder on the motor that provides constant feedback to the processor. And with that feedback information, the processor is constantly able to monitor the flow rate and constantly adjust the flow rate based on that feedback from the tachometer and the flow rate that you've set. So when we check the flow rate, we set it at 25 mils a minute, run it for 1 minute in a graduated cylinder, record the collective volume, and it should be, the flow rate should be within plus or minus 0.5%. It does indicate here that you can use the dispense mode. Not all pumps, depending on the age of your controller, has a dispense mode. If you do, you can use the dispense mode to check the flow rate. If not, then you'll just have to put the pump in the constant flow mode, enter in your flow rate of 25 mils a minute, and then just let it run for 1 minute and collect that volume into a graduated cylinder. Okay, this kind of goes into just some pump selection questions, which I don't think we really need to get into as far as the maintenance is concerned. That's more for applications as far as what type of pump application you might be running or anything like that. The main advantage of a syringe pump, of course, is the accurate pulseless flow. And really, as far as maintenance is concerned, our syringe pumps are pretty low maintenance. Basically, just regular lubrication and changing the seals. There's really no time frame as far as the seals are concerned. If you want to get into a regular maintenance schedule, that'd be fine. Most users don't change the seals until they leak. But if you want to get into like a once-a-year type maintenance thing, an annual PM type of maintenance, that would be fine. But I really don't have the seal should last X amount of time, because that's going to vary with the application that you're running, the materials that you're running, as far as seal life is concerned. You can go to our website, www.teledyneisco.com, and on our syringe pumps, we have technical bulletins, which have bulletins on field verification, pump maintenance, a lot of information on those technical bulletins.
Okay, well, we've had a few questions come in, so we will go through those. One of our first questions is there a recommended sealing material for CO2?
For CO2, I would recommend our general purpose seal. That is the seal that we've used for many years now, and that is the seal that we've had the best luck with as far as CO2, which is just our general purpose standard seal that comes with every pump that ships out the door. So for CO2 applications, that is the seal that I would recommend.
Okay. Is there a calibration method difference for a 65 DM pump versus a 260D?
As far as a pressure transducer, no. The pressure transducer on the 65 DM is almost identical to the pressure transducer on the 65 on the 260D. Only difference is the 65 DM would have a 10,000 pound limit. 260D is 7,500 psi limit. So as far as a calibration procedure on that, it would be identical.
Great. For the pressure test, do we need to use sonicated water or just water off of the tap?
You can use water off the tap. I would, if you can, if you have access to deionized water, I would recommend that, but it's not necessary. I have had customers that have just used water from the tap. That would be fine as far as doing a leak check is concerned.
Okay. Here's another question. Previously, we've used the 100 HLF dual pump system for work with methane. We're looking forward to expanding our capability with a second system. Now that the 100 HLF dual pump is no longer available, we considered a 260 HLF dual pump, but found that the available volume was too large and the pressure too low, so it's not suitable for meeting our objectives. We're considering the 100DX dual pump. Is that a safe operation for those pumps with a flammable gas, such as methane?
You can use the pump for a flammable gas like methane. The issue that I would have a concern with is on our standard D-series pumps, it is a motor. It is a motor that uses brushes. And so basically, since it is a motor it's a DC motor with brushes, you have the potential for a spark source. That would be my concern with a flammable gas on a standard D-series pump. That being said, there are customers that have placed the pumps in like a purge box that they can they surround the pump in a purge box that they can then purge that area with nitrogen. That reduces that risk. Some customers have actually drilled a hole in the case bottom of the pump and fed nitrogen to the inside of the pump when they're pumping a flammable gas. But that's the concern we have to be aware of with a standard D-series pump is it does have a DC motor with brushes. The The HLF series of pumps, of course, the motor that's used there, it's a DC motor, but it's a brushless motor. So there's no potential for spark with a brushless motor. Also, the power on switch on the HLF series of pumps is a type of switch that could not produce any type of spark when you turn the pump off or on. So those would be the concerns that you would have to look at as far as if you're using a non-HLF pump with a flammable gas.
Okay. What is the best fluid in pump for long-time use, oil or water, if you use a piston accumulator for fluid?
You can, well, you can really use either. I mean, as far as the oil is concerned, what I would maybe recommend there is after you're finished with pumping oil, you might want to rinse the pump out with like a solvent like methanol. Maybe fill the pump, fill it and empty it maybe 2 or 3 times. You know, if you've been pumping oil and it's going to be sitting for a while, I would maybe recommend rinsing it out with a solvent like that. But it's not going to, you know, it's not going to harm the pump if you leave it in oil. But if possible, I would maybe empty the pump out and rinse it out if you're going to not be using it for some extended period of time. Water, if you've been pumping water, I would once again, if you're not going to be using it, it's probably a good idea to rinse it out with something like isopropanol or methanol. That way you don't get any, you know, if water sits in there, potentially depending on what type of environment you're in, you don't get anything, any type of growth or anything inside the pump by rinsing it out with some type of solvent. But, you know, that would be my recommendation.
How often do we need to change the pump seal?
That's going to vary on your use. I wish I could give you a definite time frame, but I really can't. I would say that if you got into the habit of changing your pump seals like on a yearly PM type maintenance schedule, I think that would be fine. But a lot of it, once again, comes down to the type of use or what type of solvent you're running in the pump. If you're running something that maybe has like potentially small particulates in it, you're probably going to want to change your seal more often because that's going to cause the seal maybe to wear a little faster. If you're maybe running at a slightly elevated temperature on the pump, as far as your material is concerned, you're probably going to want to get in the habit of changing it maybe more often. But my feeling would be that if you got on to a type of maintenance schedule where you maybe change the seal every year, I think you're going to be okay.
Which is the best way to connect the pump to a Parker plumbing system?
A Parker plumbing system, I really, as far as the fittings are concerned, it's going to depend on the type of pump you have. Our 500D pump uses 1/8 inch swage lock NPT fittings as far as connections to the pump are concerned. The 1000D uses 1/4 inch swage lock NPT fittings. Our 260D and 100D series pumps and 65DM pumps use 1/8 inch Valco. So as far as Parker fittings are concerned, that's going to be kind of up to what you're connecting to downstream. If it's to a Parker system, then I think a lot of the swage lock fittings are very similar to Parker fittings as far as their configuration is concerned. But that's kind of depend on what you're connecting to downstream. I really don't have a recommendation as far as what Parker fitting to use. I can only tell you what we connect to our pumps, and then what you can connect to downstream. But I think a lot of the swage lock fittings are very similar to the Parker fittings.
The last question we'll take today is, do you have any experience with sealing for supercritical CO2?
Once again, supercritical CO2, we've always used the standard graphite Teflon seal in our pumps. We found that has been the best option for using supercritical CO2.
Great. Well, I do want to thank everyone for joining us today, and thank you to Kevin for presenting on this topic. If you do have any questions or comments that you want to speak with the group about after the webinar, feel free to email us through Zoom, or you can go to the Teledyne ISCO website and contact us there. This webinar has been recorded, so it will be available on Teledyne ISCO's YouTube channel later on this week. I also want to let everyone know that our October pumps webinar will be focused on selecting the right pump type for your application. So be on the lookout for an email invitation to that pumps webinar. And again, thank you to Kevin, and thank you to everyone for joining us, and have a great rest of your day.